Okay, so today we will discuss about the parallelogram law of vector addition or parallelogram method of vector addition. So here what will happen, two vectors will act simultaneously on a point. Let's say this is a point or any object. Let's say this is the object. Two objects acting, one force I applied on this direction and another I am pushing simultaneously in this direction, and someone is pushing the object in this direction. So two forces are acting on the same object and on a point, let's say this point. Then such cases, what will be the resultant force? Okay, when two forces are acting, or two, alternatively you can say when two vectors are acting or on a point, then making some angle with each other, then what will be the resultant of their action? Okay, so we'll calculate now. So let's say two vectors, this is, let's say, a vector and b vector, they are acting on a point or on an object, and they are acting on an object making an angle theta with each other. Let's say the angle between them is theta. So what we'll do, we'll follow the in this method, parallelogram method. This is tail, this is head of a vector. So I'll bring this b vector to the head of a vector and I'll draw it parallelly. So it will not have, because parallel vectors are same, their meaning is same, its value will not change. So I'll draw this vector b here, and similarly making another vector from the head of b vector, I will draw a parallel vector to the parallel vector from, the top of b vector making parallel to a. I'll draw another vector. Now you can, so I'll just extend this line. I'll just extend it. So if this is theta, you can see this angle will also be theta. Okay, why so? Because you know that if two parallel lines are there, then if this is a transversal, then this angle will be equal. Okay, corresponding angles. So if this is theta, this will be theta. So what we'll do, we will draw a perpendicular from here to the side. Let's say this is 90 degree, and now let us name it O. This is, let's say, P. This is Q. This is R. Sorry, this is S, and this is T, let's say. Okay, so now I'll join the line, or I'll join two diagonals, means from O to Q I'll draw one line. This is the diagonal of this parallelogram. Okay, and I'll put the direction towards Q. So this will be the resultant. Why this is resultant? You can think of your concept of triangle law of vector addition. Suppose this is your vector A, this is your vector B, then the third vector, if I'll write this as your R vector, then they are in the order, because head of one vector is attached to the tail of another vector. So these three vectors are in order. So if I started from point A, then I am reaching the same point here, O, after some time, let's say. Then I can write that A vector plus B vector plus R vector is equal to 0, or I can write A vector plus B vector is equal to minus R vector. So your minus R vector means, or I can write this one OPQ. So this is your PO vector, minus of PO vector. So I can write minus of PO vector means OP vector. Okay, negative of a vector is just the reverse. Like if this is a vector, I can write exactly same vector in opposite direction minus a vector. I can write. Okay, so similarly, O uh, minus of PO vector I can write P2O vector, I can write OP vector. So here we can get one thing, you can note that A vector plus B vector is this one, OP vector. Okay, OP vector is equal to R vector we will write, or the direction will be like this. So from here you can conclude that or get some information that your A vector plus B vector will be R vector, and R vector will be always directed opposite to the order of these two vector. Order means O to P, O to P is this is tail, this is head. Then PQ vector is tail head. So they are in order. Now the third vector which must be opposite to the order, that will be the resultant. So that we can write A vector plus B vector is equal to R vector, we can write. Now our vectorically we found out that A vector plus B vector is equal to R vector. Now we are interested to calculate the magnitude of the R vector. What will be the magnitude of R vector? Okay, so we'll calculate now what will be the magnitude. So see, now let us uh, go through the diagram. So in this diagram you can see we have drawn, this is an external perpendicular from Q to S. We have drawn one perpendicular, this is 90 degree. Now OQS is a right angle triangle. So in the triangle OQS, it's a right angle triangle. So in this right angle triangle I can write using Pythagoras theorem that OA square plus QS square is equal to OQ square. I can write. Now OS, can I write OS is equal to this plus this, OP plus PS I can write. Okay, so OS I can write OP plus PS whole square plus QS square is equal to OQ square, right? So OQ is your resultant vector, that is R vector, magnitude I can write. Okay, and if this is theta, I can write that your PS is equal to, can I write that PS by PQ, PS by PQ, PS by PQ is cos theta. Okay, because this is 90 degree, so this is your theta. So B by H is cos theta, or you can write PS is equal to PQ cos theta. What is PQ? PQ is, we have shifted B vector here, right? So PQ is B vector magnitude. I'll write this one, cos theta. So PS is B cos theta, I can write. So now I'll put it here that OP plus PS. Then what will be OP? OP is A vector magnitude from here to here. So A vector OP is A, PS is B cos theta whole square plus what is QS? What is QS? Can we write, this is a right angle triangle PQS. In this right angle triangle, can I write QS by PQ is equal to sine theta P by H. This is P perpendicular, this is hypotenuse. So I can write QS is equal to PQ sine theta, or I can write QS is equal to, what is PQ? PQ is B sine theta. Those who know how to resolve these components, they can write it directly. For the first time learner or those who are just started this vector algebra, or how to add two vectors, all these things, for them you can just uh, understand means this cos theta and sine theta like this. So qs, we found out what is qs. The qs value is b sine theta. So b sine theta whole square. This is oq square, right? Now a plus b whole square, all of you know, this is a square plus 2ab cos theta plus b square cos square theta plus b square sine square theta is equal to oq square is r magnitude, right? Or r magnitude whole square. Now one important thing we'll do here, b square cos square theta, b square sine square theta, I'll take common. So a square plus 2ab cos theta plus, if I'll take b square common, then cos square theta plus sine square theta is equal to your r magnitude square. Now cos square theta plus sine square theta, you know, 1. So I'll arrange it properly, that r magnitude square is equal to a square plus b square plus 2ab cos theta. Or I can write, or I'll write that r magnitude, the resultant magnitude of two vectors when they act simultaneously making an angle theta with each other, then this will be a square plus b square, the magnitude of two vector square, plus 2ab cos theta under root. Okay, so this is the result, and this is called also law of cosine, because cos is involved here. Law of cosine. Now we'll discuss law of sine, and also we'll prove some we'll find out the angle between the resultant and the vector a. Also we'll find out these things. Okay, so here let us solve one example, then we'll go to those discussions. So here we got the result. Here we got the result that r magnitude resultant is equal to a square plus b square plus 2ab cos theta. Now for example, if two vectors, let's say two vectors are a and b, okay, and the angle between them is, let's say, 0 degree, means they are on the same direction, then what is the result we will get? Let's say theta is equal to 0 degree. So what will happen? Now your resultant will be just a square plus b square, cos 0 is 1, so it's 2ab. So a square plus b square plus 2ab means it's a plus b whole square, or you can say the resultant magnitude is just sum of a plus b, sum of the magnitude of two vectors. That means if two vectors are acting on the same direction, like this, angle 0 degree means same direction, this is a, let's say this is b, they are acting on the same direction, okay, then the resultant will be, as expected, will be the sum of the magnitude of the two vectors. Now if they are acting 90 degree to each other, if theta is 90 degree, if theta is 90 degree, then the resultant will be a square plus b square plus 2ab cos 90. So 90 here, cos 90, you know, is 0, so the resultant will be a square plus b square root of. So in the same way, for different angles you can find out the resultant of two vectors. Now we'll proceed towards finding out the angle between the vector a and the resultant. Okay, So let me draw another diagram for that and we'll proceed accordingly. So now what we'll find, law of sine, or we can say the angle between a and the resultant vector. So here let's say this is your vector a and b vector, they are acting at a point. Now this is your b vector again, so this is your parallelogram and this is your resultant. Now we have extended this one and this is your 90 degree. The total angle is theta and this angle is, let's say, alpha. The angle it's make resultant vector making the angle with a vector, this is, let's say, alpha. Okay, and here let's say this is angle is beta. Now what we'll do, we will draw another perpendicular here to the resultant from this point. Okay, we can draw now by taking the rounder, we can draw the perpendicular. So now what we'll do, uh, we will consider, we'll name the triangle, let's say O P, this is N, this is, let's say, S, this is Q. Okay, so now we'll consider, let's say, in triangle, we'll consider, let's triangle OSN, this triangle OSN. Okay, so in triangle OSN, okay, it's a right angle triangle, so we can write that Sn is equal to, this is alpha, so Sn will be Sn by Os is sine alpha, sine theta is P by H, Sn is P, H is Os, or we can write Sn is equal to Os sine alpha. What is Os? Os is your R vector magnitude, so ultimately we are getting Sn is equal to R sine alpha. Similarly, we can write that in triangle PSN in this small triangle, this is also a right angle triangle, so in triangle PSN, let me box this one, PSN, Sn is equal to, okay, directly I'm writing Sn is equal to, this is theta. Okay, so Sn by Ps is sine theta, or Sn is equal to B sine theta. B sine theta. Now let's say this is equation 1, this is equation 2. So from equation 1 and 2 you can see here clearly that your left hand side Sn, so right hand side must be equal, so I can write R sine alpha is equal to B sine theta. So I can write that R by sine theta is equal to B by sine alpha. Okay, I can write, I got one relationship. Now I'll consider two more different triangles and I'll try to find the relationship between beta. So now if I'll consider these two triangles, that is this is M, point M, this one is M, so PM, okay, PM is, this is your beta, right? So in triangle PMS, in triangle PMS, PM by PS is equal to sine beta, or PM is equal to PS sine beta, or what is PS? PS is B, right? This one PS. PS is B, vector B. Show magnitude. PM will be B sine beta, right? Okay. So let's say this is equation 3. Now let us write another uh, relationship that is in triangle OMP. ये वाला triangle, this triangle, OMP. So in triangle OMP, your similarly PM by OP, PM by OP. OP is the hypotenuse. This is your perpendicular. P by H is sine theta. So here angle is alpha. Sine alpha. Or you can write PM is equal to OP sine alpha. OP is A. I am writing directly OA sine alpha. So now this is equation 4. So you can see from 3 and 4 you can write left hand side is equal, so right hand side will be equal. So that's why we can write that so we can write B sine beta is equal to A sine alpha, or we can write B by sine alpha is equal to A by sine beta. So here you can see one thing, R by, this is suppose let's say relationship X, and this is a relationship Y. Okay, so now you can see in X and Y, R by sine theta is equal to B by sine alpha. Here B by sine alpha is equal to A by sine beta. So can I write from means combining this X and Y relationship? So I can write, we can write that R by sine theta is equal to A by sine beta is equal to B by sine alpha. So this is called law of sine. This is called law of sines. Now to remember this law easily, what you can do, you can use one trick that you can see R by sine theta. So R is the hypotenuse, so it will be related to theta, and A by sine beta, you see in front of the vector A, okay, so you can see one thing, in front of this vector A, your beta is there, so your A by sine beta. Now in front of vector B, alpha is there, so B by sine beta, just to, B by sine alpha. So just to remember this law, you can think R by sine theta is equal to A by sine, A from in front of A, beta angle is there, A by sine beta, and in front of vector B, alpha is there, so B by sine alpha. So to remember this law of sine. Now another relationship we will discuss, then we will complete the derivation of this parallelogram method. Here what we'll get another relationship between your alpha and the vectors. So you can see that your vector r, or this magnitude r, we can write in this way, like, what is tan alpha? Tan alpha will be this one, on by Sn. On by tan alpha will be Sn by On, because P by B. Okay, this is P, this is B. So in this triangle, now let me discuss another relationship, or quickly let me draw this again. This is A, this is B, this is your, again, sorry, this is A, this is B vector, this is B vector. Okay, now this is parallelogram, this is your resultant, this is your alpha, this is your beta angle, the total angle is theta. Now we have extended this, drawn a perpendicular. Okay, and here also we have drawn a perpendicular. This is M, this is, I have written O, P, M, S, Q. Now you see what is tan alpha in this diagram. What is tan alpha? Just one relationship we are doing. Tan alpha is equal to, and this is helpful in solving many problems. Sometimes the question asks that what is the angle between the resultant and vector A. Okay, so it will be P by B. You know, tan theta is P by B. Here in this triangle, in triangle OHN, ये वाला triangle में, in triangle OHN, tan alpha is P by B. So P is here Sn, B is here On. So Sn is, let's say, let me write Sn, and On is OP plus Pn, right? OP plus Pn, or I can write tan alpha is equal to Sn, or Sn I have written at the beginning. Sn is, this is also theta. Sn is this is your B vector. Sn is B cos, Sn is B sine theta, and Pn is B cos theta. So I can write B sine theta, B sine theta by OP is A vector, A magnitude, A plus B cos theta. So this one is an important relationship to solve many problems. Okay, sometimes the vector magnitude of vector A and B will be given, and the angle between these two vectors will be given, and the question will be asked that what is the angle between A and the resultant. So you can use this formula or explanation to calculate the angle between your resultant and vector A. Okay, alpha is the angle between resultant and vector A we have considered. So accordingly you can use this formula in your problem. So with this, I think we have completed almost all the uh, aspects of when two vectors act simultaneously on a point. Vectors can be two forces acting on an object, or any other vectors you can think of. But when they act simultaneously on a point, then what is their magnitude, and what are the relationship between their different angles, and also finally what is the angle between the resultant vector and the vector A. Okay, so we have calculated all these things. Thank you. Maybe some problems I will discuss in the next video. Thank you.